Aleatoric uncertainty. Here is the key idea that uncertainty does not come from model or algorithm. It already exists in the data before any learning happens. In this video, we will deep dive into this. Aleatoric uncertainty refers to uncertainty that comes from randomness in the data. This uncertainty exists before any model is trained. Even if we delay modeling or change algorithm, this uncertainty is already present in the real world process. Even a perfect model cannot remove it completely. This is why aleatoric uncertainty is considered unavoidable rather than modeling mistake. In this world, it is already there. Now, let's see even how it's caused. It is caused by noise, variability, ambiguity in the observations. Noise means a small random fluctuation. Variability means natural changes, and ambiguity means unclear or overlapping situations. So these are the causes of this uncertainty. Now let's see where the word aleatoric comes from. Let's start this discussion. The word aleatoric comes from Latin word alea, which means dice. In Latin, alea refers to dice or games of chance where outcomes are inherently unpredictable. No matter how skilled you are, you cannot control the outcome of dice roll completely. It represents randomness built into the process itself. This perfectly matches how this type of uncertainty behaves in machine learning. You want me to roll this dice? I can rotate it. I will leave it aside. Let's talk on built-in randomness. So we are quite clear that aleatoric uncertainty cannot be removed. If I mispronounce, please forgive me. So randomness is part of reality, not something that model can learn away. And this randomness, we can say it's like built-in randomness. Why real world data is inherently uncertain? Real world measurements are never perfectly precise. Every measuring device has physical limits which introduce small variations in readings. Sensors have physical limitations like physical limits or noise that we can see sometimes in zigzag data set, like if we take the example of sensor noise. Even high quality sensors cannot eliminate noise completely. Human observations and labels vary. Different people, like if I say the high in spike is noise, and like if someone can say that smaller one are like the noise. So based on situation, like people have different judgment or context. So we can say like natural variability. Some phenomena naturally fluctuate over time. These fluctuations are real and unavoidable in natural system. Example like temperature prediction we can take. Consider predicting temperature at a location and at noon. Temperature seems like single number, but in reality it never perfectly fixed. So I'm trying to create a thermometer. Okay, let's leave it here. Let's see. So multiple sensors measure the same temperature. Each sensor captures the temperature slightly different due to noise and placement. Each sensor gives slightly different readings. None of these readings can be considered exact true. There is no single exact value everyone agrees on. This disagreement reflects in real world randomness. Like not a model error. This variation is aleatoric uncertainty. This uncertainty would exist even without any machine learning model. Why more data does not remove it? Adding more measurements does not remove randomness. More data helps us understanding the distribution better, but randomness remains. Averaging reduces variation. Like if we do average and we can reduce the variation, but not we can eliminate it. Even after averaging, some spread is always visible. Like randomness comes from physical process. This shows the uncertainty is rooted in how the data is generated. This is why it is called irreducible uncertainty. Irreducible uncertainty cannot be removed or only managed. Like example, blood pressure. Consider measuring blood pressure for same person. Blood pressure naturally fluctuates even when a person is resting. Multiple readings give slightly different values. This happens even with the proper medical equipment or instrument. This variation exists even with the good instruments. So uncertainty comes from the body, not the device. This aleatoric uncertainty is not model based. A model cannot remove this variability completely. In ML, let's take the example like same input we are giving and we are getting it leading to different outputs. One X and many Y. This happens because the data itself allows multiple valid outcomes. We can see this in classification, like class boundaries overlap. Overlap means no clean separation is possible. Like we can see, make a diagram of touching circles here. So this is, we can say, two data sets, they are overlapping. Even in images, visual uncertainty is common form of aleatoric uncertainty. This is an image, but here we can see some blur or occasional can add the noise. Sorry to make it, well, it's my drawing only. So we discuss visual uncertainty, like even data level uncertainty. All of this is aleatoric uncertainty. The uncertainty is inherent to the observations. What it is not. Electronic uncertainty is not a bad model. A strong model will still show aleatoric uncertainty. It is not lack of training. More training data cannot remove it completely. It cannot be removed with infinite data. Infinite data only reveals the uncertainty more clearly. It reflects two problem difficulty. The problem itself has variability. why model does not, why models must account for it. Let's discuss this part. If we ignore this aleatoric uncertainty, it leads to overconfidence. Overconfidence makes predictions look more certain than reality, and that's not good. Model becomes too precise for noisy data. Over precise predictions, like thin layer we can see in our models. This prediction is misleading in real world settings. Let me draw very thin layer line. Okay. Good models reflect uncertainty honestly. Like honest uncertainty improves reliability and trust. This improves safety and trust. System can behave more uh, with more reliably. It works as a shield we are giving to the systems. It is working more cautiously, and when needed it is behaving accordingly to the situation. Electronic uncertainty comes from data generating process. It is rooted in how the world produces the observation. It exists even with perfect model and with infinite data. No algorithm can eliminate it completely. It cannot be eliminated, only modeled. Model must learn to live with this uncertainty. Understanding this is essential for trustworthy trustworthy AI. Like mm, this is damn important. So let me mark with this uh, star that essential for trust is for understanding this uncertainty. We need to understand this. Reliable system acknowledge uncertainty instead of hiding it. So this is damn important point, and we can end this topic here. Thank you so much for watching.